Hi, welcome to this tutorial on MasterCAM 2021 Home Learning Edition. And we have a new version out, but this will work for all intensive purposes. So today we have an electric guitar solid body. Um, this is something I designed in Fusion 360, although I like programming in MasterCAM a lot more. So this is kind of a cool project to work on. We get to run the gambit on a lot of different tool paths. We have pockets, contour, we have holes, and we also get to do the front and back of this thing. So let's go ahead and get into it. So first thing I'm going to do is right click. I'm going to go into my top view. And then we're going to have to go ahead and position this thing. We're going to move it to the top 4 coordinate system, which is right here. I have my graph enabled to show it. So first things first, let's go ahead and draw a bounding box for our stock. So went into my levels tab here. If that's not viewable, you can go to view on the top tab here. You can turn on and off different tabs in this window. So we'll go ahead and go back here. So we're going to level 2, we're going to call it stock, and just hit enter. Make sure that's the one that's activated right now. Then we'll go to wireframe. We'll go ahead and draw a rectangle from our origin point right here. Should snap. And we'll do 19 inches by negative 14 inches. So if you haven't guessed yet, our origin point, or our work coordinate system, is going to be on the upper left corner here. So the next thing you need to do is go ahead and select your solid body. And we're going to do a dynamic transform. You can click anywhere. We're only going to move the X and Y. The X over here. And we'll move the Y up right about there. Just anywhere in that stock bounding box will work. Go ahead and click OK. Let's go to our front view. And perfect. So we're going to be working with all Z negatives. So you'll be able to touch off your tools on the top of the stock here. And then that'll work great. So next thing we need to do is go to machine. We'll go to mill. We'll go to default. We've got our tool paths. We have machine group 1. And then under your properties, let's expand that options. And then we'll go to stock setup, where we will select corners. That one, down to that one. And then our solid model is 1 1/4 inch, so 1.25. Go ahead and select that. Let's go ahead and open that back up. Go to display so we can see it. And perfect. Go to fit. Absolutely wonderful. So next thing I like to do is, we don't have a solid contour on this. It's kind of a 3D contour, kind of wraps around, does all kinds of funky stuff. So the great thing about MasterCAM is they have a silhouette option for outlining 3D models. So let's go to our levels again, and let's make a 3, and then we'll do a contour wireframe. So, and then under the wireframe tab, we'll select silhouette boundary. We'll go ahead and select our solid model here, and click OK. So now we can hide our 3D model, and you can see we have a nice silhouette boundary. We have a couple holes with that, which is fine. That'll work. So back to our top view. And then under tool paths, we'll go ahead and face it. We don't need to select anything. It's going to work off our stock setup. And let's go ahead and create a tool. Let's do a face mill. Do 2.9 by 3. And it just likes having two different diameters there because it wants to compensate for a tooltip radius. So that's fine. You could program it to whatever you have. I mean, this is actually like a design guitar, so you can machine this if you'd like, if you want to, but you could. So for spindle speed, we have 3,500, feed rate 60, plunge rate 25. Then we'll go to our cut parameters. Under style, we'll go to zigzag. Overlap, we'll do 90%. The rest of these settings look just fine. And we're not going to leave any stock on the floor. We're going to go right down to the solid model top. And then under linking parameters, we have a retract of 1/4 inch, feed plane 0.2, 0.1, and I like to almost exclusively program in absolute mode. Depth is 0. This looks fine. Under our planes, our work coordinate system is going to be the top. And for coolant, we're going to be off. We're going to be machining wood. So here we go. This is going to plane the top of our stock. So we could go ahead and preview that with the back plot. We play. And then I generally like to check the back plot after I do some programming, make sure it's not doing something I don't like. You can kind of tell with the toolpath lines that it leaves, but sometimes it's fun to watch. That looks pretty good to me. So I'm going to go ahead and hide this now. I'm going to hide this toolpath with the squiggly lines in our toolpath window. Perfect. Next thing we're going to want to do is let's do contour. So we're going to be in wireframe. We're going to select chain. And then, so if we're looking into the window of the machine, I usually like my tools to plunge somewhere where I could see them. So if you go ahead and click that. If your arrow is pointed the other way, you could correct that. So when you do outside profiles, you want it to go clockwise. If you're doing an inside pocket, you kind of want it to go counterclockwise. And that's just to ensure that you're always doing climb milling, not conventional. Okay, click OK. Tool. We're going to create another tool. And we'll do a flat end mill. We'll do a 1/2 inch. We want our length of cut to be at least 1.5. And that's just to make sure that the cutting length of the tool is cutting all the way through the part, so you're not rubbing on the shank. 1/2 inch. That's going to be fine. Click finish. Feed rate, we'll go 90. Spindle speed, depending on the machine you have, you might be limited in some aspects. We'll go to 12,000 on this one. Plunge rate 25 is fine. We're just going to be plunging into wood, so we don't need a helix or anything. Our entry. Cut parameters. Under compensation type, I always like to use wear. That's it's just a good thing to use for like resharpen bits or your dimensions that are coming out right. You could always adjust your tool radius or tool diameter depending on how your machine operates. Contour type is going to be 2D. Compensation is left, and that's going to be climb milling. And stock leave on walls is 0. Stock leave on floor is 0. Lead in, lead out. You're going to need this if you are using wear, and that's to use the tool compensation in the machine. You can't just, you need some kind of linear movement to engage the tool comp. So we can just leave this as is for now. The depth cuts, we can go ahead and do that. Do a 1/2 inch depth cuts. Finish step. Go ahead and leave that at 0. We don't need anything fancy. If you did want to machine this, you'd have to make a fixture plate, so you'd be machining kind of fixture plate or particle board or whatever you want to use. We'll let it retract out and plunge back down. It'll be fine. For depth, we're going to do negative 1.3, and that'll be 50 thou below the part, just to make sure that you get all the way through. Feed plane, we do 0.1. Perfect. Again, I like to use absolutes. It'll most likely post out in absolute anyways, but we'll go ahead and use that. Then click OK. Let's see what it does. So our lead ends are kind of big there. It's going to be fine. Another thing that we might want to do is if we go back into our lead in, lead out, and our overlap, do like a 1/4 inch overlap, and that's just kind of to make sure that it doesn't leave a little nub there when it's done. So you can see it comes back as a dirty operation. Go ahead and click regenerate all selected operations. So I'll go ahead and do that. And then we could go ahead and backplot this. See if we like it. Plunges in, goes around. And so far this is looking pretty okay. All right. So next thing I want to do is probably going to go ahead and do through holes on these. Drill them out anyways. And that's just, I like to do that before I pocket in, just so I don't have to drop the Z value. So if there's no material there, you don't want to peck air. So we'll go ahead and just drill those out, and then we'll come back and do the pockets. So we'll go ahead and do our drill. And for these are 1/8 inch holes. So go ahead and select your hole centers there. These are going to be a different diameter, so we're going to use a different drill. Normally you would do like a center drill or a spot drill before you drill, but this is wood, so it's not that critical. Alright, and then again for wood, we'll do like 1500. Oops, I forgot. We gotta make that. We gotta select our drill. These are going to be 1/8 inch. You can type it in, or you can go down and look for it. Which typing it might be a bit faster. Let's see. Inch screw machine. Heavy duty jobber. It won't really matter. You'll know the drills that you need. So click finish. 1500 ought to do the job. Do 25. And then cut parameters. Probably do pecking. It will be kind of aggressive with your pecking on wood. You just want to clear the chips out. Even though it's wood, it's really soft. It will burn up just because the oil's in the wood. Not your tool, but it will burn the wood, so you kind of want to get those chips out. And then, we're using 3 axes. Depth. Again, you want to go past your taper on your drill. So if we're going to go negative 1.4, should get us all the way through past the drill tip. And then retract 0.5, do 0.1, and then we'll have a dance between the parts around 0.25. Or not between the parts, but between the holes. Absolute perfect. Go ahead and get that. And then for these holes, I'm not sure of the hole size. I think it's 157 or something like that. But we can analyze the. See what's going on here. And here it is. We have a hole diameter of 157. So we'll go ahead and go to our tool tabs here. Drill again. And you can just select all of them. Whoa! That's more holes than there is. It's twice as many. I guess I'll just manually click them. Just make sure that you're in the center of the hole. Click like a quadrant or something like that. So tool, we're going to create another tool. Drill. Let's look for that. I'm not sure which number that would be. 157. Number 22 drill. Yeah, that's fine. 25. You can spend these pretty fast, not too much. 2,000 probably be fine. Then same thing, pack depth. And then again we have negative 1.4. Cut parameters is a peck drill, 25,000 or 250 thou peck depths. So we're good there. Okay. All right. So we'll go ahead and turn off the 2D wireframe. We'll bring back the solid model. So activate solid model. We'll turn off the 2D wireframe. So we have a couple of holes here that did not show up because they're not through holes. So we'll go ahead and drill those. Let's see what size they are. Analyze entity. And this is 80 thou. So we'll go ahead and go back to our tool paths and drill. Let's see, I misclicked that. That's not good. So you can click the whole face and get the center of it. Perfect. Okay. And we'll create another tool. Create this drill. That was an 80 thou. 81 probably won't hurt. And we'll do a job. And then cut parameters. This is a thinner drill, so we'll probably do less of a peck. Do 1/8" pecks. Usually the general rule is the radius of the drill for the peck depth. But depends on what you're doing. Depth. This is going to go down 1 inch. Absolute clearance, perfect. So if we click on our toolpath group, turn on all the tool paths. So far we're going to plane it, contour it, drill all our holes, And then the next thing we need to do is we can go ahead and do our pockets. So let's go ahead and do that. I'm going to hide my toolpaths again. So we need to figure out what these radiuses are, and then we can figure out which tools we're going to use. So home, analyze entity, click that arc, and it'll tell us the radiuses. So it's a 3/16 radius, 0.187. And then, oops, let's check that smaller arc. And that is a 0.1 radius. So, we're probably going to end up using something a little bit bigger than that, radius-wise, to get in there. But it should work just fine. So, first thing we're going to do is probably the pickup cavities. So we can go ahead and go into our toolpaths again, and then this time we're going to go down to our pocket, and we're going to select our 3D, or solids tab here, and then we have our loop interface. So we can select this, and then also select that. Perfect. And we can just use our 1/2 inch to rough it out. We'll do 12,000 feed rate. So I went pretty fast on the outside. The inside we could go a little bit slower, probably about 60, just so the machine's not banging around constantly. And then this, we want to leave a little bit because we're going to come back in with a smaller diameter tool to clean up the corners. But we don't really care if the floor goes to 0. So we'll leave about 20 thou on the sides. Roughing, we have a lot of options here. Just go ahead and do a parallel spiral. Fine. I don't really need an entry motion. Can just plunge right down into it. Finishing pass, this is just going to be a roughing operation for these. And then depth of cut, probably don't need that. And then for depth, I click the depth tab, select a point on the bottom of that. So we're going down 0.7. Feed plane, 0.1. Retract, absolute. Okay. Now what happened? Didn't go in there. Oh, it didn't save my depth. Okay. Negatives. Oh. There. So we can, I'm going to go ahead and save this before we get too far ahead. We'll just call it tar body save. I don't know. I just think things right. So for this toolpath, I'm not exactly certain what it's going to do, and then backplot will give you an idea. But if we go to verify, it's going to show us with the stock what it's going to do. So go ahead and do verify on that. And we can slow this down a little bit. In, out, in, out, in, out, in, out, in, out, in, out. Okay, perfect. So then I'll probably just come in with the 1/4 inch. Well, actually, while we have that tool, we should probably just do this pocket, right? Snack pocket. Knock all that material out while we can. So these ones can be a little bit tricky. We have an overhang. It's not, you know, it's not exactly certain what it's going to do here, but here's what we can do. We can do partial loop. Select this, it's going over here, and then see that it comes out. We have this little edge, so it'll come in, go around. That's kind of what we want here, right? Actually, I'm going to cancel that. I should have it come out. So let's go ahead and do that. And we need to flip that. Correct. Yeah. Okay, so now we have kind of a bridge there. 1/2 inch, 12,000. 60 here. We can do full depth on this one as well. Depth cuts. Cutting parameters, under standard, we're actually going to go to the open option now. For this one, we don't have any sharp corners, so we can actually let it finish this time. We're going to do finishing passes. We're going to leave 20,000 for a finishing pass. And we'll also do the wear option for the For depth, we're going to select right there. Okay. Okay, we got an error. Let's see what's going on. Did not like. Did not like what I did at all. Alright, let's take a look. Gotta get rid of that toolpath. So there is a problem with the solid. I didn't catch that when I modeled it, but we can have a workaround. So let's go to wireframe. Let's go to levels. Let's create another one. We'll call this neck pocket. And then we'll go ahead and do curve one edge. So this is going to give us 2D curves that we can then use to cut this pocket. It's actually quite a nice feature. Click OK. We'll hide our solid body again. And then for this, we actually have a because the model was messed up, we could do an extension, 250 thou or something like that. So we can go ahead and go to length, 0.25. Click this edge, sticks it out, perfect. Okay. And now we can go to our toolpaths and do a pocket. We're going to do the open pocket, right? So start and a finish. And then for tool, this 12,000. Do 60 IPM. cut parameters. We're going to go to pocket type open. We're going to machine right to the walls. Overlap. That's probably fine. That absolutely is fine. And we could use open pocket cutting method, and that'll allow us to use these options here. Or, sorry, with that off, we can use these. My mistake. Step over 50 thou. That's fine. For finishing, we're going to turn that on. We're going to turn the wear on. And I'm going to leave it at 20 thou to come back and clean up. Depth is perfect. This is all good. Click that. And you know, it's not going to do the job, is it? Oh boy. I didn't actually plan this out, but see, that's not going to clean that up out there. So we do have a way to fix that without getting too wild. So we can go back to our cut parameters. This overlap right here is where it's detecting the broken chain, where it can freely move the end mill out. And right now, it's 5/8. So why don't we do 1.5? See what happens right there. And then there, we have some wasted space right here. It's going to be cutting air, but it's going to machine the pocket, which is fine with me. So now, we can go ahead and hide that toolpath. Let's select our toolpath group, and sorry, I got a quick little save here. Sometimes when you hit the verify, things go bad. So let's verify. Let's see what's going to do to the stock. So we'll slow it down. Good. Going out the pockets. Going out our neck pocket. So far, this is looking pretty good. So let's go ahead and close that. Do a quick little save again. While these are all selected, go ahead and hide the toolpath lines. So now we need to come back in and hit these corners with a smaller end mill. So let's go to our toolpath, sorry. And we're going to go ahead and go to contour. And we're going to go to our solids, so we can select solids. Do these chains. Do that one. And then, like I said before, when you're doing inside pockets, you want it to go counterclockwise. So those are both going in the right direction. And we'll create a tool, and we're going to create a 1/4 inch mill here. And finish that. This one is going to be about the same. 60 cutting parameters. We don't need depth cuts. Let's go back to cut parameters. Wear is fine. Yeah, we don't want to leave any stock. That's good. And then linking parameters. Go ahead and click on depth again and select the bottom of your pickup cavity. This number's all good. So apply. Okay. It's going to come in, clean up that pocket, clean up that pocket, and then for the next thing, we're going to have that. Actually, yeah, we'll just go ahead and use the quarter inch to clean up these bottom pockets here. So we'll go ahead and go to pocket, select that one. We're just going to be selecting the floors. We have all of our geometry selected. We're going to go back in. We're going to use the quarter inch. Make sure everything's moving properly. These are kind of small pockets. We'll go a little bit slower. 30 RPM. We're going to go to, it's not an open pocket, it's a standard pocket. Roughing, constant spiral, that's fine. Entry motion off, finish. Yeah, that'll work. For finish, one pass, 20 thou, and cutter compensation is set to wear, which is perfect. Linking parameters, depth, it should have gotten it because we selected the actual floor of the geometry. And then click OK. So here we go. We'll go in there, whip around, relieve pockets, and then there is about 2 more toolpaths that we need to do on this. We need to do a roundover contour on the outside of this, and then we also need to do a surfacing right here, which isn't that complicated to do. So we'll go ahead and do that. For the roundover bit, we're going to go ahead and, well, let's go ahead in here and hide all our toolpaths. And then we're going to go to levels. And we're going to go to our contour wireframe again. And then go ahead and hide your, we can hide the neck pocket wireframe as well. So we need to round over just about everything. So we could do a partial where we just round over everything but the neck pocket, or we just let the tool, it's not going to take very long, so I'll just go ahead and do the whole thing. For that, we're just going to do a contour. Same deal, we want a link chain and make sure it's going clockwise on the outside here. So tool, we're going to create another tool. Let's do radius mill here. Tip diameter, we'll do an 1/8 inch. Cutting is going to be an 1/8 inch. And then the radius is actually going to be an 1/8 inch. So, bang. This thing you're also going to want to spin it quite fast. We'll go around at 60. Make sure it's finishing properly. Lead in, lead out, we don't really need that. Well, sometimes you get the tip diameters a little inconsistent, but we'll go ahead and run it with the computer comp. And then depth, we're going to go down 1/8 of an inch with an 1/8 inch radius. These numbers look good. Cutting parameters are good. Click OK and apply. So then we can do background toolpaths tab, backplot. If we go to our front view, we should see this drop down. By the way, these roundover bits are really hard to get right without overcutting the top or digging into the side. But with wood, you should be able to sand everything out. Alright, cool. We got a roundover, and the only thing that's left to do now is our surfacing. So we'll go ahead and hide all these toolpaths again. then in our levels, we're going to go ahead and turn on solid body and then turn off our contour lines. We want to make sure our solid body is the one that's selected. So toolpaths, 3D. We do flow line. We could do parallel. I'm going to try flow line. And for this, we're just going to select our surface that we want to surface. The surface you want to surface. And then we can go ahead and select the radius on the outside here. And selection. That's fine. Check surfaces. These are surfaces you don't want it to touch. So we don't want it to touch the top. We don't want it to mess with the radius that we just did. But we want it to get close. So we'll select the sides. Like if you had a piece of tape, you would tape off everything that you didn't want to paint. So it's kind of the same thing with this. Just select all the faces you don't want your tool to touch. So in selection. And then for flow line, we'll go ahead and click flow line. Let's see, that looks pretty good. It's going to follow the arm cutout right there, which is good. Okay, that looks pretty good. So we obviously need to create another tool, and we need to create a ball mill. And I'll go ahead and use a 1-inch. It's a 1-inch ball mill. It should be fine. It's not going to do anything crazy. And then for surface parameter, retract, feed, yes. And then step over control. You don't need it that fine, but you don't want it to be super far apart where it's really difficult to sand down and blend and stuff. So we'll leave it at a 1/16 of an inch, 0.065, and zigzag's fine. Go ahead and click OK. Check and drive stock to leave are identical. That's fine. It should. Did not like something there. Let's try it again. We'll just put a check surface on the top, see if it likes that better. Cut direction, that's kind of what we want right there. 8,000 spin. Make sure you select the right tool. For this, you can go pretty fast with it. It's not going to be too wild. Distance, again, 0.065. Looks good. Alright, there we go. Now we have it going. So let's go ahead and verify everything. You could also do a machine simulation, which is kind of fun to do. I'm going to save it. You go to your machine, and then under simulator, you click that arrow. You'll get this option here. You want to use a giant 5-axis beast. That'll work. It's probably too small. Which one will work best? Not a lot of options for built-in machines. All right, let's use the A2 5x Como. Simulator automatic. Table. No one used this thing before. It's kind of interesting. Let's do 36 inches by negative 12. And then we'll raise it up 2 inches. Say that's where it's going to land on the machine. I don't know. Let's simulate. Let's see what it's going to do. This is kind of overkill. Well, it definitely looks like the y is supposed to be positive and the x is supposed to be negative. So I gotta close that. We go back to this and do our simulator translation. X negative, y positive. It looks like we do 24. Yeah. Let's see how that fares. That'd be better. Alright, cool. So we have it on a machine simulation. If you have a machine like this, you're going to have a lot of fun with it, I can tell. So I'm going to slow it down, and then you'll watch this thing get made. Then you're an operator, you're on your phone, watching YouTube, listening to earbuds, machine's running. You should never do that on your first program, but be careful about that. Yeah, that's a really slow down. And over here, it kind of gives you an idea about the time. So, like 6 minutes. Something like this, I imagine, would only take about half an hour or so. So we got our roughing pocket out. Our neck pocket's done. Okay, we got those. Still the little pockets. Perfect. I don't think you should machine at rapid speeds, but the simulator just does that for some reason. I have no idea why. Everything's looking pretty good on this thing, huh? It's following the spindle right now, so it's kind of busy. But we'll take a look at it when it's done. Here we got our arm cut. It says it's plunging into the it turned red because it was hitting the stock there, but we should be alright. Everything looks pretty good on here, eh? Our rounder over looks beautiful. Our arm cut looks pretty good. I did forget to add the radius going along the bottom of it. But you could just go ahead and go back and click that. It'll be fun. Our pockets look good. Our neck pocket looks good. So I'm going to say Op 1 is now programmed and ready to machine. And then I'll go ahead and post another video for the backside. Should be about similar. Thank you for watching. Bye.